We get it going here.
Cool.
Yeah, we are recording, and I will mute myself. Jason, you are now in control.
All right, cool. Well, good afternoon, everybody. Again, appreciate you taking some time out of your, unfortunately, maybe not as busy schedule as we'd like to, but hopefully we can get back to being busy again here fairly soon. But today we've got a presentation from Opus on advanced driver assistance best practices. I've got Bob Pattengale with us this afternoon. Bob's got over 38 years of automotive experience with stops at OEM dealerships, some independent repair shops, technician training, equipment sales, parts supply. So a lot of different avenues in our industry. Bob's also a contributing writer for Motor Magazine, and he served on also served as the SAE Service Technician Society president in 2001, 2002. It's pretty cool gig there, Bob, for sure. And Bob, like a lot of us, enjoys fishing and hiking and enjoying a cold one every once in a while with some friends and family. So with that, I'm going to turn over to Bob and welcome him.
Very good. Glad to be here. Still early in the Tucson zone by comparison to the East Coast, but great opportunity to take advantage of, what I like to think is the slowdown period, right? For us to get caught up on a lot of activities that we may not have spent time with. And I think the training aspect of it sure is kicking in, because I've done quite a few more classes online over the period of time here. So a little bit more on my background. I started working on cars when I was about 12 years old. My dad worked at a Dodge dealership for 42 years, had some experience in the alignment area, as well as working on collision alignment for the body shop was in the facility there. And then last 13 years, I was with Robert Bosch Corporation, Director of Training. And so we spent quite a bit of time with the ADAS technology through the years and safety systems from the Bosch perspective side. Went to work for the Opus IVS group last summer. So we've been heavily focused on this particular topic of ADAS, and most everyone has been to a theory of operation class. What is a radar? What is a camera? How does it work? But when we started digging into what does it take to actually perform a calibration, that's where there was a lot of open interpretation. So it was hard to find individuals who had spent a lot of time calibrating vehicles. So this class is based upon a concept of what does it take to get your shop prepared to calibrate vehicles, or maybe once you look at the circumstances, the pieces, the steps that are required, you might find that you're going to have to find an ally, another shop in the area that has the space and the capability to do that. So the picture on the right is somewhat daunting when you look at all the different pieces of components that may be needed in order to calibrate vehicles. But in the particular case of a shop, there may be only certain pieces of those devices that you need. A lot of these items that are displayed in the background here are simply camera targets. So if you're not replacing windshields, if you have somebody that does that particular job, typically you won't need to have all those boards with all the targets. The bigger percentage of the business that we find, we have a couple of research centers, one that we have in Scottsdale, Arizona. We have another one in Huntington Beach, California. We're ramping up another research center in New York, and then also one in Dallas and eventually Michigan. So we're doing calibrations every day just to get that experience and working together with shops. But it will depend upon what you need to do. And more often what we're seeing is more of the radar calibrations, both in the front and the rear of the vehicle. So what I wanted to just bring is an example. We're going to use a Honda a little bit in this example because they've done a really good job of consolidating their information. And if you see the evolution of the technology, lane watch camera was really the first thing that was added to a Honda vehicle. That's a little camera that sits on the side of the mirror. It's sort of that introduction to blind spot, but it's more a physical strategy where when you turn your turn signal on, you get to see a display in the panel to determine whether or not there's a vehicle in that particular area. So the next thing up for them was adaptive cruise control, forward collision warning. Those particular items would primarily be associated with a radar component that you see here. Lane departure warning would then become the camera piece. So as we add these individual components, the marketing names for these particular devices and systems come into play. And as we go further down in the path, once you have a radar and a camera, then you can start making additional decisions. So collision mitigating braking or lane keep assist. So we have a camera that can tell us that we're drifting into the other lane, and it can provide the warning that we need. But the vehicle at that point in time does not do any mitigation to try and help us stay in the lane. That's where the lane keep assist comes into play. So in the early stages, these components work pretty much autonomous with one another, that they would provide the warning information, but they were not fully integrated with other systems. If we go with the collision mitigation braking, the lane keep assist, road departure mitigation, these are all systems that now tie in electronic stability control, electronic steering, those types of systems where now we fully integrated with the car and working our way towards, you know, what we see out of the vehicle as true autonomous vehicles there. Then they've added in the blind spot information or the blind spot technology and cross traffic monitor. You might have a blind spot system on the vehicle, but it doesn't do anything more than warn you if a vehicle's approaching. If you have the right kind of technology, now the vehicle can stop itself as it's backing up. We've all seen the commercials where the vehicle gets put in reverse and it won't let you go anywhere. And it's kind of an interesting deal. We've been working together with SEMA on a few projects related to the accessories that get placed on cars. And it's interesting, as you start making the list of all the pieces of technology that are out there, you put a bike rack on the back of the car. Seems totally simple process, and now you put it in the reverse and you can't back up. Well, that's because now there is an object that the camera is able to see that makes a decision that we're not going to allow the vehicle to back up. So that's just the evolution of Honda. If you throw an Acura, for example, the Acura never had a lane watch camera. They did surround view. So these are the different components that are involved. The bottom line is, if the shop is involved in a calibration strategy, these are the components that we have to deal with. So breaking it down by calibration strategy. So many of the vehicles out there have a dynamic calibration strategy, which means that as long as the component, the camera, the radar, whatever the device is properly positioned on the vehicle, and in many cases there will be a set of instructions that says, you know, please check a vertical, horizontal, or a particular measurement. And as long as that is within a specified bubble range, then you're all set. So you would click the button on the scan tool and take it for a drive, and that would do the dynamic calibration all by itself. No need for any targets, no need for any extra adapters or systems to do that. Then we have what we call static calibration, which is where we need a physical target. We need a radar triangle, we need a flat board, we need a variety of devices where we're going to make sure that the radar, the camera, any of the components are in their proper position before we would go to a dynamic calibration. And some of the research that we've done on purpose is taking a particular vehicle and aligning it exactly the way the recommendations tell us to, and then take it out for a drive. So for example, a Honda Odyssey, we may put the camera, targets, and move them within the field of range to where it still passes, but it's a target width wide. And then take it for a drive and see what the strategy is for dynamic calibration. And it's interesting that although the vehicle will learn, it takes longer to learn. So part of the reason for static calibration is really to get you in the proper mode to expedite the time of your dynamic learning. And in some of the vehicles where we purposely moved the radar or the camera just to, you know, create that you're in the zone, but you're outside of the perfect recommendation, it took 2 times, 3 times as long to finally get the message on the scan tool or on the instrument cluster that it was calibrated. So then finally, we look at mechanical aiming without a scan tool. Now this picture to the right here depicts a Honda Accord. And in essence, there's my blind spot radar. And we set this target system up. And what we're going to do is we're going to put a laser and we're going to shoot it to a board. So in that particular case, there's no interaction with the scan tool whatsoever. It's simply making sure that the look of that camera is going to shoot in a particular zone. And we'll show that as we get further into the presentation. So different types of calibration, and that's where researching the particular year, make, and model becomes critical. And this is something that happens in the field. I have personally done it myself. when we first started doing Honda and Acura vehicles. I did a ton of Hondas back to back to back, cameras and radar calibrations, and I'd set the vehicle up. And then we brought an Acura vehicle in and we said, okay, well, it's a Honda, right? It's an Acura, it's basically a Honda. I set the whole vehicle up. And in the end, I did the distance from the target from the center of the wheel, which we'll talk about a little bit more in the presentation. And I could not get the vehicle to calibrate. And then I went back to my instructions and I went through it step by step by step. And only then did I realize that Acura did not use the center of the wheel for measurement from the distance of the target. They used where the plumb bob, the front of the vehicle, to create the distance. So it's important to look up the service information for your make model because they can change between the manufacturer groups. Okay, so best recommended practice. I always like to add this into any class that I put together throughout the years, is just this logical sequence and flow. Being a trainer for many years, but also being a technician and providing hotline support on technical programs. A lot of technicians go by their gut feelings. They have a pretty good idea how something works. Sometimes they go down a path because they've seen it before. And what happens is maybe the result is not correct. You thought it was going to be this part that would fix the vehicle because you've seen it set up out of 10 times. So rather than diagnosing and checking it, you just put the part in and it didn't work. So I always like to have this plan. So in this case, review the customer issue. Now, depending upon the situation of a collision vehicle, in many cases, the vehicle had already been to a collision shop. It had already been repaired and given back to the customer. And in many cases, some of these systems, if the system has been turned off and is not active, some of the warning messages and issues that may be affected with that particular system may not reveal themselves until that system is put in an operational mode. If the blind spot is turned off and the car is delivered back to the customer and all the road testing occurred with the blind spot system in the off position, there is nothing to tell you that you have a calibration issue. So when it comes in, review the customer complaint. If it's a mechanical shop that may be working on a vehicle that recently come in from another source, ask them, has the vehicle been in a collision before? Were there any components removed for service? Those are the type of questions that'll be helpful to streamline the process. Can it be duplicated? So if the customer's complaining about the vehicle is not using the lane keep assist strategy on the vehicle to move it back to the center line, what are the things that are associated with that? Can you duplicate that the blind spot LED or the image that's in the mirror, it's not illuminating on the right, but it's illuminating on left, making sure that you can duplicate it. If you're unable to duplicate the problem, it's best to not continue on in the process until you know that you're able to replicate the customer's concern. We've all been there in the past where the perception of two different people driving the same exact car can be completely different. So it's important to grab that in there. What portion of the system is affected? And I always like to break it into segments. And from a diagnostic perspective, is it physical damage or calibration? Do we have fault codes in the vehicle that reveal a particular problem? You know, in the aspect of scanning, many of you probably do pre and post scan on vehicles. The code tells you a lot as to what needs to happen. The code description will many times point you in the direction. An example will be rear park sensors. If I have one rear park sensor with a fault code that's an open and short type, I know it may be associated with wiring with that. If all 4 park sensors in the back have an issue, now I know it's got to be something related in the wiring harness that is agreeable to all those components. Networking issues, so we're just trying to narrow that down. If the camera or the radar is not communicating, there's no way that you can go into the calibration strategy if I have a networking code creating the issue. Research the system, TSB reprogramming. What are the things that you need to know? It's always important in the ADAS system strategy to look at the technical service bulletins and service information because there can be some changes along the way, and we'll talk more about that in just a moment. Develop a diagnostic calibration plan. What do you need to do the job? So it should be a notebook, a piece of paper, however someone keeps track of it. What do I need? I need the Honda factory scan tool or equivalent. that has these aiming strategies available in it. Do I have the triangle? Do I have the jig that I need to do the job, right? And that lays into researching where the tools are. If you do not have the tools that are available, that becomes a stopping point. Because if you don't have a triangle, if you don't have the measurement devices that you need, you're going to have to figure out how long it will take to get that. Now, in our particular situation, as we've ordered systems and components, when we've needed multiple pieces, for example, if you want to do a Toyota radar calibration or blind spot, you need basically a hold up stick, and you need a triangle. It's not uncommon to get a hold of the service information, go to the Toyota site to order the device, and find out it'll be weeks before you can get the particular component. So it may not be something you can get next day aired to you. It may take a few weeks. We've ordered several components back to back, and in many cases, by us ordering 2 or 3 sets of something, it created a backlog for a period of time to get the tools that you need. So execute the diagnostic and calibration plan. If you run into issues, document those. And then I added an 8th step to this particular issue because documentation and legal implications become a big deal here. And this is something that every shop's going to have to make a decision on. Is this particular style of technology at some point in time, people challenge the validity of the repair or what you've done right or wrong. Sometimes it ends up in court. This is going to be something that you're going to have really good documentation to show what you did. And that's going to include pictures, taking scan tool capture so you got the backup of the information, and demonstrating that. Opus IVS is working on a strategy with our customers to develop a certification program or a credential that you can get. So if you want to work together with our company on remote assistance programming, you can set the triangle up and we can potentially use the factory scan tool to use the factory calibration strategy. But we have to work together in some format to make sure that we're all on the same page. All right, so this is kind of going to go in a sequence now of those steps that you would go through. So identifying the equipment, service information is not always accurate for your make and model. And this is one of the items that we see regularly. We've had some vehicles brought to our research center for calibration. Examples of 2019 Toyota Camry came to the shop a couple months ago, and they wanted to have the blind spot learned and have the other systems checked. So we started the process, and we went right to the mirror, and we said, there's no icon, there's no image in the mirror, and there was no LED on the inside. And sure enough, we checked for that particular vehicle. It did not have blind spot technology. And the shop that brought it to us said, well, come on, it's a 2019 Camry. Why wouldn't it have blind spot? I thought every car had all the features. And that's not always the case. I rent a lot of cars. I travel all over around the United States for training and projects. And I rent from Hertz. And sometimes it's difficult for me to find a car that has fully ADAS equipped technology. It's random. A lot of the Chrysler 300 amps do not have adaptive cruise control. They may have forward collision warning, no camera, no blind spot, no adaptive cruise control, only a radar for forward collision warning. So it's going to be important to identify that. We worked on a project to see whether or not the VIN number would be able to tell us the information that's on the vehicle. And without a sophisticated database from each manufacturer, the VIN number doesn't even give you a decoding strategy to tell you which technology is on which car. So bottom line, what does it come down to? Visual inspection. Is there a camera in the windshield? Is there a radar in the front of the vehicle? Now, some of them are easy to find. You can see a cover that's over the top. Some of them are behind an emblem. So you may have to look a little bit for the radar. Check the mirror for images. So do I see the little option there? And also on the instrument cluster, do I see any messages that pop up to show me the technologies that is there? So, checking that vehicle to make sure the technologies that's there to validate what equipment is on the vehicle itself. Another way to do this for a more sophisticated technician is to scan the car. If you scan the car, and in this particular case, let me zoom in here. In this case, you can see that the modules in yellow, these are all the modules that might possibly be on this 2019 Camry that we're working on. So it could have had blind spot, but if we scan the vehicle, it will go out and check to see which of these modules are available. So after scanning it, these will turn white, would be the ones that have a communication. So if the blind spot monitor, master, and slave are not highlighted, then we know that is not equipped on the vehicle. So that's a quick way to tell with the scan tool, but again, that would require a complete scan and then checking all the modules there. I think a visual inspection is a little bit quicker from that particular strategy. Okay, service information, where would you find it? Most of you have access to either an ALLDATA, a Mitchell, some type of an aftermarket information subscription. Some of you might even have MotoLogic as an availability as well. Different aftermarket systems that are out there now. The difficulty with aftermarket systems is sometimes the information is spread out in different areas. Sometimes you find it, sometimes you don't. But a good thing to always remember is that every single one of the car manufacturers has a OE website that's available, and there's a short-term subscription. And if you write something down for today, nastf.org, nastf.org is a great website to go to that will give you the OE websites, what does it take for programming, what are the subscriptions, how about the factory scan tool. If you have an issue with a particular car brand, you can't get a part, you're unable to get a tool, there's the service info request. You can request information that goes directly to the OE. So there's a lot of information here at the National Automotive Service Information Task Force, but this is a great place to go to get the authentic OE service information. So when we do a calibration in the Research Center, we will go to the factory website. If we don't already subscribe to it for the year, we will buy a short-term access and we will print the exact OE instructions for that year, make, model application. That way we know that we're working 100% the way the OE is working. And when I access the OE site, I'm getting the latest information, and I also have the latest TSBs available to reference there. So a good resource to have, bookmark that, the type of vehicles that you're working on. In many cases, particularly late model vehicles, in many cases in the collision world, we know you're working on 2019s, 2020s already. We've already seen some of those at the shops that we work with in the field, that they're already seeing 2020 models with less than 200 miles on them that are already in the body shop. So those are vehicles that you're not going to find that information in the aftermarket service information to be able to reference. So this here is the Honda factory website. So for 10 bucks, it's $72. And in this particular case, they have some videos. So these are 2 videos that talk about how to do camera aiming, what is their aiming strategy. They talk about this aiming driving support system document. Honda and Acura, I think, have done the best job of creating a consolidated document that goes from start to finish of all the things that you need to know to calibrate. So it describes all the systems, all the components that are involved in the systems. And they talk about the individual tools and then how to set up the vehicle that's there. So in this case, 2016 Honda Accord, we just searched for radar, and these are all the search criteria that came about. And it tells you what we need to do to calibrate the vehicle. So the millimeter wave radar, let me just zoom in, might make it easier for you guys to see there. So this is a mounting position inspection. So after the vehicle has been in a collision, it's being restored, you got everything aligned back up, you can check the mounting position of that, where that radar is going to mount, just to make sure it's in proper position, to see if you have any movements there. There are different procedures for a 2-door and 4-door. So although you may think the strategy for calibration is similar, there are differences between the different brands of vehicles that are there. And then right here is the millimeter wave radar aiming instructions. So this is a portion of the website. So we grab the aiming support document, and this is that document here that we talked about. That's the job aid. And then this is the service instructions that we see here that talks about looking at the spacing, which we'll talk more about in a moment. And then what are the tools that were needed? So we needed this stand that has one of the aluminum triangles on it. and then it will go step by step through the process. So in your review of service information, you would have reviewed the service procedure and then said, do I have this available to me? Then does my scan tool that I have in the shop, does it have the ability to perform the radar aiming and calibration component and portion? So you would use your information there to determine if it's that. Now, if your current aftermarket scan tool is not capable, if you have a J2534 compliant interface, you would be able to rent the Honda Acura software, the HDS software, to perform the calibration. And in most of the cases, we're either using the factory scan tool or we're using we like to use the right to repair equivalent software, because that's typically more what a average shop would be. It's OE software, but it's using the J2534 interface to allow you to perform the calibration. So we're trying to emulate what we think an average shop might do if you didn't own every single factory scan tool. So reviewing that service information again, technical service bulletins. So this happened to be a TSB for a Honda radar, where there has been a change in the serial number and the rollout of the right and left blind spot radar. So if you had a right rear collision and you needed to purchase a right blind spot radar, if the newer one that you need to put in is newer than the one that's on the left-hand side, they need to both be replaced. And if you didn't look at technical service bulletins, you may have gone and said, yep, it needs a radar, order one up, you get the new part in, you put it in there, you put the bumper and everything back together, only to learn that you have a mismatch between the two. And by the way, on a particular Hondas and Acuras, the bumper cannot be on the vehicle for calibration. We'll talk about that in just a moment. So if you jump the gun and you didn't review the service information, you may have installed a part that then is going to have to be properly matched up with another device. So TSB look definitely has a benefit of going through the calibration process. So this is the tough part right here. So the homework assignment for the shop owners that are on the call is to take the information that you're seeing here of the research that we have done amongst all the different brands of vehicles. Honda and Acura has generally the largest area that they're requesting for working. So in this case, you're looking at the dimensions, 33 feet from the front of the car, 10 feet height. Now, why are we talking about this? Because the radar, right, when it sends out its radar waves, it's looking for anything that could be in the background that may bounce back off the radar. So although some people have gotten away with a shorter distance, this is what the OE is recommending. So when you're looking at your strategy, maybe you calibrated the vehicle fine, and it seemed like you had the radar aimed, you had a successful message. But think about, later on, if that vehicle were to have a problem, if somebody came to your shop and said, show me the area where you calibrated the vehicle. What if you only had basically 20 feet of working space? Would that be acceptable or not? So these are the things you have to consider when you look at what would be reasonable expectations to do it correctly versus what you could defend in a court if you had to do that, right? We hope that would never come to that if we do it properly, but these are the things that we have to think about with this style of technology more so than other things that we've done in the past. So this is that space for radars and cameras, and this is for lane watch. So if you're going to do a calibration of the mirror with the camera that's shooting back towards the back, there'll be a target placed here. So you need to have space around there. Now, typically on the camera, targets are more susceptible to lighting issues because the camera is trying to look at the image on the target. Radars are more susceptible to objects, metal and physical objects that are around it. Now, you'll notice here on the blind spot, let me zoom in on this. We have a pretty large area for the blind spot, 13 feet from the corner of the vehicle. And it's interesting that when I show you in a moment, the static calibration that we do with this, there's no interaction with the scan tool. So we're not really even turning the radar in, we're just shooting it directionally. So when you look at that particular aspect, you say, well, if I'm doing a Honda and I don't have 13 feet, but I'm on a level surface, because you're just using a laser pointer to a target, you could make some decisions there to say, you know, I'm not trying to send out a radar wave to a triangle. I'm just using the radar to a particular point. So that'll make more sense here in just a moment. Okay, what tools are required? Now, I like to use the Honda example again, just simply because, in essence, they have radars in different positions. So it's not just one triangle. Depending upon the vehicle, sometimes you have the radar on the right side of the vehicle. Sometimes it's in the center of the vehicle. Sometimes it's on the right side and left side, and sometimes it's behind the emblem on the grille. Some of them have an offset. Some of them use a bubble gauge set up, some of the early Honda vehicles. But that's, again, where the tools come into play. Maybe you bought this triangle, and now you have a vehicle in the shop, and you're thinking, oh, yeah, we can knock this out, piece of cake. Then you go to the service information and find out that basically it's a different component that you need to solve the problem. So again, make sure that you have the tools available to take care of the particular calibration. So scan tool wise, that's a decision that you have to make. Once again, does the aftermarket scan tool do the job? Do you have the OE scan tool that you need, the Nissan or the Toyota, or whatever the case may be? Does your aftermarket scan tool have the capability of doing it? And in the case of remote assistance programming, which our company offers, certainly we have the ability to communicate to the car. We have the ability to communicate to the car with a factory scan tool, but we're going to have to work in concert with the industry to work on a very solid strategy so that we know the technician that's measuring the vehicle, setting up the targets, doing all the detail stuff on the vehicle is following the same instructions that the remote assistance person would. Now, if you're doing it from start to finish, you have the service information, you have the tools, you have the scan tool. That process, you know, works differently. You're in 100% control of the process. But if we have two different entities, one working at a remote location, another working physically at the shop, you have some considerations there. Okay, so let's say that you've reached this point, and Jason, I don't know if you want to pause it at this point to throw out any questions or anything that you've received, or we'll just keep going. I'll leave it up to you to communicate and let me know.
Yeah, let's do that. We've got a couple of questions. So the first one was, if when we're hooking the scan tool up to the vehicle, if that customer has disabled a feature, will that module still communicate with the diagnostic software?
That's a great question, and yes, the module will communicate, and you'll be able to talk to the module itself, pull any codes from it or wherever the case may be, but the actual user setting, that's going to be typically in the user interface of the display for the customer itself. So yes, the modules will communicate.
Okay. And Buck, I'm going to ask you to clarify your question a little bit. Like, what exactly are you looking for in your answer? And then while you're doing that, maybe if you could type that while I ask Bob the next question I've got here is, can you kind of briefly, kind of in layman's terms, but kind of technical at the same point, when I'm doing a static calibration, what exactly am I doing as far as, it's looking at the target, what am I doing to that when I'm doing a static calibration from a technical standpoint? If that makes sense.
That's a great question. What you're ultimately doing, and I'll throw a piece out there for that particular question, because somebody, why are some manufacturers just doing dynamic 100%? Why are some manufacturers doing static, and then I also have to do dynamic? The idea with static is to get you very, very close to the dimensional characteristics of where that component should be. So the goal is, and in many cases, you guys are in the collision industry, you got one shot to make sure that all these components are positioned correctly. Because by the time you put the bumpers and the fascias and the grills, if now you have a problem with it's vertically out of calibration or horizontally, it's twisted, it's bent, you're gonna have to take the whole front of the car, back of the car apart in order to get that done. So what static does is ultimately get us to where we're as close as we can be within what the manufacturer recommendations specify. So for example, on a radar triangle, what we're doing is we're sending out a radar signal to reflect off that triangle, and then that beam bounces back into the radar, and it's able to measure the deflection between the radar. So if you twist the triangle, if you twist it, like for example on a Nissan, we, in our research center, in addition to calibrating it correctly, we see if we can replicate the fault code. So in the case of a Honda, it says that if it's greater than 30 millimeters, if the target is not placed square to the radar, if it's twisted by more than 30 millimeters, you're going to get a fault code. So what do? We angle the triangle 35 millimeters, and we see if we can get the fault code. And in that case, we were able to get a fault code. We make it 25 millimeters. We're able to get it within calibration. Now, what's the difference? If I'm 25 millimeters, I pass the test, but I'm quite a bit off from the pure direction of that angle that the radar is supposed to work, right? So when I go for a dynamic drive, the vehicle says, yeah, the radar's there, but it's not really as fine-tuned as we want it to be, so that it has to do some learning. It has to look at objects in different positions, and eventually it'll make an internal adjustment to get back to square. But by statically lining it up, we make sure it's as close as we can make it, just as if it's rolling off the factory. That's what we're doing with the static. It's getting as close as we can to the way that vehicle was born.
Okay. Very good. So another question we've got, when it comes to customized and modified vehicles that have been, lifted or lowered, do you have a recommendation for how those would be calibrated? Now, you mentioned SEMA earlier. I don't know if you've been involved in the work that SEMA's been doing with some of the, big tire and wheel and lift kit companies or not. But what would you do in a situation where we've got a vehicle that's been lifted or lowered potentially?
Well, it's a tough question, and we have to stick with, what's legally accepted at the moment. What's legally accepted at the moment is only modifications that have been recommended by the OE. So if an OE offers a 2-inch or 4-inch lift kit and they have a calibration strategy that is for that particular year, make, model vehicle, that would be considered acceptable. If you modify a vehicle and there are no recommendations from the OE, then it might be considered acceptable, right? But it's not technically legal. So there's really no defense of that at the moment. That we are involved with SEMA in that project. And what we're trying to do is figure out, is there a good process that we can go through to provide information that would allow individuals to modify the vehicle and then safely perform the calibration and demonstrate that everything is working as it should be. So it's a pretty big project. There's a lot of pieces and parts to it. The OEs are involved, in those strategies. So, more to be learned from that. But from a legal perspective, all we can say is if the OE has not recommended it and they don't sell that accessory, and again, different than a dealership, right? A dealership could lift a vehicle. They could put big tires on it. They could put a brush guard on it, a winch. They could do a lot of things to cars. A dealer doesn't always do what the OE recommends in many cases. So we always have to be careful there, that just because they bought it from the dealership that way does not make a 100% certainty that it was designed to have that as such. So hopefully that answers that question. Not an easy one.
Yeah, it points us in the right direction for sure on that. And I think, and I know that there's a lot of work to do yet with that project, but maybe in the future, Collision Hub can host John and SEMA, and when they've got kind of some results from that in the future. So,
yeah, it's a great project. It's going to be very interesting. We're, our piece of the puzzle is working together with them on how to teach people how to properly calibrate a vehicle when it's OE authentic. Okay, so what are all the steps you have to do, just like we're talking about here, and then after that, then going down the path of saying, okay, now modify the vehicle, now see what the results are based upon those modifications in relationship to how you would aim the vehicle from there. So, that's kind of our piece of the puzzle at the moment.
Okay. Awesome. That's it for now. We just have one more comment here from Dean real quick. A plow truck or a truck on a plow could potential problem. Absolutely could be a problem with a plow, brush guards, things of that nature, which is one reason why Ram on the Ram 1500, the new models, they've got everything up in the windshield area to avoid that. Maybe we'll see other OEs move to that as well. Doesn't account for certainly the lift or the lower of the vehicle, but it definitely moves some things out of the front of the vehicle, grill and bumper area. So with that,
Absolutely.
We'll let you carry on.
Okay. So again, on this particular case where, you've reached the point where you've decided that you're going to calibrate the vehicle, right? You've got the tools, you've got the proper training, you've got everything that you feel comfortable with, and you just kind of go down the process, right? You know, does the radar that you're calibrating, whatever the component is that surface clean? Check for any aftermarket suspension modifications, because there is an area for write-out. So we have a worksheet that we actually go through, that we check these items off, and we check the tire sizes are correct according to the door jamb. Are the tire pressure set according to that portion there? Is the full tank, the fuel tank full? And it's kind of an interesting dynamic. And I've asked this question a couple times to OEs. I used to PDI cars at a dealership. I never seen a single car ever come into the dealership with a full tank of fuel, ever, right? So as a mechanical technician, there's only one time a car comes in with a full tank of fuel, and that's when it's on the tow truck and it's got a bad fuel pump, right? That's the joke of the day, right? But rarely do we have consistency as far as fuel levels concerned. And OEs that I've asked this question to say, oh yeah, I think we make an adjustment, and they probably do, because they have a strategy involved there. But keep in mind, a gallon of fuel is about 5.5 to 6 pounds. So when we calibrate a vehicle, we go to the service information, we look at it and say, okay, it's a 20-gallon tank, it's around a half a tank. We have to make an assumption we're probably going to be within plus or minus a gallon. So we say 10. So we add 60 pounds to the trunk of the vehicle to make sure that we have the proper ride height of the vehicle. Remove the cargo if there's any extra items that are there. This is always that important deal, that the level floor. Now, our experience is going to be very difficult in many shops to find a very level floor. Consistently, within a few degrees is where you want to be. If you have a floor that's sloped, but it's consistent for a long distance, we found that those will generally calibrate with pretty good certainty. But this is an area that many shops, that's going to be the sticking point, right? Is finding that area that you can do it within the shop. Now, a good trained technician, it won't take them much more than 20 to 30 minutes to calibrate an average vehicle once they're trained. So if you have the drive-in area of your shop, it's a nice level area with space around it. Although people couldn't come in and out for that period of time, you could use that space to do your calibration. One of the Honda dealerships that we worked with, they have a center area in the shop, but they typically will keep vehicles overnight, and there's a group of guys that do the calibrations after hours, so that doesn't disturb the flow of the shop. So every shop's got a little bit different strategy they work with there. Verify the steering wheel is pointed straight ahead, and then shift the transmission to park or apply the parking brake. So we're just prepping the vehicle, making sure that everything is where it needs to be for the calibration strategy. So perform the measurements according to the OE recommendations, and the depiction that you have here is this little curly cue. What you're seeing here, the instructions talk about using a string. So they have a string set up, is what Honda uses. They have a pogo stick that you typically stick on the back for the center of it, and then you pull the string through the front after you've made your centering mark there, and then you pull the string out to the front of the vehicle, and that is your marking point for center. Now, we'll talk more about this in just a moment, but you guys know the collision world, you know the things that occurred. A lot of times the centering point that they recommend is on a tow hook. So what are the chances that the tow hook is perfectly centered? That's going to be some decisions that you have to make in the field. And of all the calibrations that we've done, we feel pretty confident that using a centering off the emblem, which I'll show in just a moment, is generally, as good as you're going to make it if you're looking for, nice tight calibrations. Also, pulling the string depends upon how well the person is going to be at making sure that it's taut, that it's going across the center point. When we teach other technicians how to do this, we make them use this strategy here on the first measurement of a Honda or an Acura, so they know exactly what the factory recommends. We make people do exactly the way Toyota does, and then we talk about what are other methodologies that you might use that would be accurate, if not more accurate. Now, typically, when someone uses a string method, they're usually within plus or minus a ½ inch, right? Or about 10 millimeters. We've seen the string taunt as far as 50 millimeters off. So this can be a concern of your accuracy of calibration. Again, we'll talk more about, what are the alternatives that you can do. So you see 4,000 meters from the center of the wheel. And I talked about this earlier. I set up an Acura exactly like this. And then what I found out later on was the instruction said that the 4,000 meters needed to be from the front of the vehicle, not from the wheel. So it was creating my problem with the calibration. So this is a method that is fairly well accepted amongst most of the individuals. In fact, some OEs do it. So a lot of the things that you see that I'm talking about here, we have used recommendations from other OEs. So for example, in the case of Toyota, they recommend using a very simple string with a plumb bob, very old school, put it up on the hood, drop that down the center of the emblem, and then put your marking for the center for the front and back. So that would be your centering mark that you're going to use. Others have used, so you can see there's a, let me zoom in on this a little bit more for you. So you see there's a mark, so we used a plumb bob to drop back here. There's our centering mark. And then we have a laser that's basically going to shoot from the front of the vehicle to help for center. Now, when I was in Germany and they were teaching the Bosch way, they were working on a strategy that said, what if we put a block on the top of the vehicle and we shot a laser from the front that went over the top of the vehicle? And then you could see that piece of 2x4 has got a black and a white, and it sets it up on the antenna. Now, most DOEs did not feel comfortable with the antenna strategy because they felt the antenna, placement might be a little looser than potentially the emblem in the back. But again, those are decisions that as you calibrate vehicles, you become more comfortable with. Yeah, I feel that I'm as tight as I can make it when I'm performing the calibration. Now you'll see that I also have a block of wood here. We've experimented with using inexpensive range lasers to come up with dimensions of distance for squaring up the target. So we're always experimenting with different ways to calibrate the vehicle or do the setup and find ways to streamline the process. So that's another picture that shows there's the laser kind of shooting down the middle. You kind of see that there's a little parking paths there, but it's kind of going down the center, goes over the top to the block there. Let me zoom in again on that. So you can see that laser's kind of going down the middle. Somebody's got a parking path there, and we were shooting to show where we'd be at. And a lot of times what we do this for is say, okay, what is a strategy that we have seen someone else use? Now let's see how that works if we try it on another vehicle. And then let's try the string strategy on the same vehicle if that's the OE strategy. We're just looking to see what methods work and what methods may not be as accurate as others. There's that laser shooting across that centering point to work with that. And then in this case, there's that laser that you happen to see here that's shooting off of the calibration bar that helps us square up the jig. Because all we're trying to do ultimately is find the center line of the vehicle, right? What's our goal? Find the center line and then square up the jig to where the target's square with the vehicle. That's the whole process that you're ultimately going through when you're doing your setup for calibration. So the next step is to mark the distance. So we've talked a little bit about that there. We've got our center point, we've got our thrust angle zone, but in reality, once I have the centering point, now I need to know the distance, and now I need to make sure that this target is squared up to the vehicle. So that's the process that we work through there. This happens to be a picture from the VAG, from the Volkswagen Audi Porsche strategy, where there is, on the VAS 6430 stand, there is a tape measure. So you take the tape measure and you run the tape measure to the center of the wheel. And then you've got a tape measure on the other side, and all you're trying to do is center or square up the jig to the front of the vehicle. So this is another component that we use. Some people like to use tape measures. We experimented with the idea of using a track, and we set these two $29 Bosch measuring distance lasers. So it shoots a laser out, and then we put a 2x4 basically, where that center of the wheel is, where the center of that wheel is. And then we had one person stand at one side, another person stand at the other side and say, okay, I'm at, 4,000 meters, and where are you at? So we work back and forth to get the center point to where we can square up the jig. So again, just different ways. We're experimenting with some mats, some different things. You know, we're trying to figure out what is an accurate way to do it that we could carry across many lines that would help the technician setup be faster. This is the most time investment you're going to have is getting the target in the proper position squared up to vehicle. That's going to take the most time of the entire calibration process. Everything else after that's pretty straightforward. So this is prepping the target. So in this case, they show that there is a centering point. The service information will tell you, turn the target around and move it to where you're at the centering point. Then in many cases, you'll see I have a mark here on the side of the stand. So this is the point they wanted us to have the level of the target, but then they give us an offset measurement to get the setup for the proper height. Some of them have to require different position points because the target goes through several height positions during the calibration strategy. In this case, many of the lasers just say get the laser point to the center of the emblem, and the radar is right behind the back of it. So in essence, you've got that centered up from there. So that's the VAS 6430/10. That's the Volkswagen Audi Porsche board that they use that also has tilt in it. All right, so this one here, if it happened to be a blind spot radar, this is where you've got to do this with the bumper off. So one of the early vehicles that we did more than a year ago, we were called into a body shop to do some research, and we'd ordered up all the Honda tools, and we had several vehicles that are there. We had one that came in that they actually had a blind spot problem. They had delivered the vehicle to the customer. It went out in the field, and about a week later, the customer came back and said, my blind spot's not working, and they had an issue with a light being illuminated saying that one of the systems is not functioning correctly. So we brought the vehicle back, scanned it, and sure enough, there was a calibration error with that particular vehicle. So we got all our instructions out and we started down the path, and then we read the instructions and said, hey, we can't do this with a bumper on. So what was interesting to us is this vehicle had actually already been to the dealer, and it had been supposedly calibrated, right? We think that everybody's going to do everything exactly the way they should. But in many cases, many technicians feel, hey, if I can reset the codes and basically drive the vehicle around the block, if the code doesn't come back, the vehicle's fixed. We know that that's not always the case. And the reason we know that is multiple of these vehicles came back with an issue. And that's because after it was driven for a while, the right and left start comparing notes for targeting. And if it sees a variation, sees an issue, it comes back with a calibration issue. So in that car, we had to take the bumper off, and we had to go through the process of lining up the laser to the box. Now, the box is pretty big. If you think about that, remember, Honda and Acura said 13 feet from the corner of the car, but we're shooting to this flat panel target. And anywhere, as long as it's later, anywhere in this area, you're within the calibration zone. Now, typically, we would like to see this more towards the center. This block also has 3 different positions, 0, 1 millimeter, 2 millimeter. So it's very important to read the service information because you got to know which portion of this block needs to be facing up in order for the laser to be pointing in the proper direction. So that would be that mechanical static calibration without scan tool interaction. Okay, so now we're up to this point in time. You're ready for the scan tool. You have your radar ready to go. You have your marking points. Let's say you're doing a camera calibration. You got everything where you need it to be. Now's when the scan tool comes into play. So I'm going to show you a series of screen captures that show you what you would do with the factory scan tool to do this particular job. So driving support, it'll tell you in service information, go to that particular module group. We're going to calibrate the radar in this case. And we're going to perform this for the radar function. Make sure you refer to the service manual. Click the check mark. Now, I've added a few boxes here. So if I had gone to the service information and I'm following it step by step, first perform the vertical aiming procedure, right? Refer to the service manual for proper procedures. Park it in a suitable location. Now, the scan tool is assuming that you are following these directions, that you have the proper space. So if you get an error message on the display or the scan tool, you got to be thinking, do I have the proper dimensions? And then we run in this with a few shops that were doing remote calibrations, called us up for help. And I said, okay, send me a picture with your phone of what does the front of the vehicle see? What does it see in the background? And we immediately seen that they had objects that were in the distance in the front that could potentially reflect back in and create confusion for the radar. So make sure you have the proper information set up there. Marking the target area. So in essence, it's saying you should have already done this. Do not set up the aiming target yet. And what that really means is, do not put the target in this position here yet. You're going to wait till it tells you to put in the target. So in essence, what they're saying is, first of all, when the radar gets lit up, we want to see, is there anything in the field of view that could create a reflection? So the first thing it wants to do is, if it sends out a signal, does anything come back? If nothing comes back, that means that the area behind the vehicle where the target's shooting for is correct. You don't have any obstacles that are creating an issue for there. So then following the service information, step 1, place the radar target at the specified lower position. After setting the target in the front of the vehicle, hit enter. So in this case, we have positioned the target exactly where it says it's supposed to be based upon the offset values we have, and we've got it set at the proper position. Now we hit enter. Now this is a more complicated setup. So this is one that uses a multi-position. So this was our Y position. This is where we first set it up on the bottom of the radar. Then what it asked us to do is, on our calibration pole, we need to set a Y1, a Y2, and a Y3 dimension, and those dimensions are available in the service information itself. So right there is the dimensions that we're talking about. Let me zoom back in again. So here's the A dimension, right? There's our B dimension, and then there's our C dimension. So we're putting these marks on the pole so that when we go through the process, it's going to tell us where to move that position. What is the radar doing? It's shooting out where it believes center should be. Then you're going to move it to an elevated position, and the software knows, if I shoot this laser to that position, it should bounce back at a certain level. And if it does that correctly, so yep, that's good. Then it's going to move it into the next position. So it's really doing a field of view calibration. In the case of Volkswagen, Audi, Porsche, they have a tilt board where the flat board, you actually tilt it 2 degrees in each position so that it has that reflection. So it's basically trying to calibrate the reflection point between the distances of the target. So then it tells us, place the target at the lower specification. And if you're reading the service information, you're also going to have a message on your instrument cluster. So in this case, if you look at the instrument cluster, if you have the target that's not in the field of view, it'll say target not present. If we put it in the field of view, it'll say, hey, the radar target is okay. And now once you're in that position and you've got it at the proper step of step 1, now you can hit the next position by hitting the check mark. Then it says move it to the Y2 position, right? So we're going to move the target upward. So we're here, now we're going to move it to there, and then we're going to hit the scan tool button. And then the scan tool button says step 3, right? Move it to the next position. You notice here that it's not giving me Y3 or whatever. It's saying go to the specified upper position, right? So I'm following the instructions step by step, but please be aware, this box here will not be in your scan tool. I've done that there for the purposes of the video to help you understand the steps that are in that process. Now, once it's gone through that process there, then it will know if it's out of calibration. And look at how tight that spec is. Plus 0.1 degree is my current spec. What do I need to be? Allowable range minus 0.1 to plus 0.1. Not even a degree, not 1.0 degrees. It wants 0.1 degree. And it will not let you typically go beyond this point. And it tells you down here, while the HDS displays measures angle within plus or minus 1 degree, the value changes according to the angle of the unit as you adjust it. So there's these little screws here that you rotate to get in the proper position. And you have to rotate a little bit. It tells you which direction to go, but then you have to back away from it and let it read. So you really need 2 people to do this job, or you need the ability to get your scan tool displayed down by you to where you can make the adjustment. So this is where having 2 people working together on the job is very helpful going through the process. Now, once that's done, now we've done vertical, now we need to do the horizontal adjustment. And it says, in this case, we're going to do the horizontal adjustment, do not put the target in place, then hit enter. So back again, take the same exact target out of the way, and then put it back in its place. And in this case, the instructions told us make sure the target was at the Y2 position as we had specified, and then put it back in place, and then enter. And then the radar aiming calibration has been completed. If you have an error message, it means that something is not correct. You need to go back in the process to see what you've done. Typically, if it's outside of that calibration spec, it won't let you go beyond that point. So one key point that we're going to make right here, and we have seen this happen in the field, individuals believe the process is done, but ultimately the process is not done until the ignition switch is turned off, and then the ignition switch is turned back on again, and that would in essence write the calibration. So a lot of things is in volatile memory that's being operated, and it needs to basically do the final write for the calibration to deploy. So, following those step by step, some require key on, key off at multiple steps in the intervals, and you have to go through that process there. Okay, so in quick review, best recommended practices, right? Review the customer issue. If you're in a collision shop, it's been in a collision, right? This is where, we see a lot of work being done in the field. How can we prepare for these particular issues? It's a right rear hit. Does it have a radar? What do we need to do? If you see a right rear hit and you walk up to the mirror or there's an LED, it has a blind spot radar back there. You're going to have to write that into your estimate. It's a process you have to go through. Can you duplicate the problem? So after a road test, if it's a particular issue, that's what we're teaching mechanical shops that work on vehicles, 4-body shops. Do you truly understand what the issue is? Is it a customer perception issue? Is it the system's just not turned on? What is the case there? What portion of the system is affected? I mean, this one here, I cannot stress enough. Research, research, research. This is what'll get you tripped up in the calibration. And again, I'm doing for personal experience that I have made some assumptions along the way. Man, every Honda is the same. Every Toyota is going to be done the same way. Every vehicle is going to have a similar process. Once I do one, it'll be similar. In some ways it is, but when you get down to the very, very specifics like ride height levels, a lot of the camera radars have a distance where you measure from the wheel lip on each side. And then you have to do the math calculation to determine what is the current ride height pitch of the vehicle, and then make an adjustment for the pitch of that vehicle to make sure that it's calibrating the camera. Mostly that comes in the camera. Develop your diagnostic plan. Do you have the tools? Can you borrow the tools? Can you rent the factory scan tool? Do you have a J-box? Execute the diagnostic plan if you have an issue. Going back through your steps of your diagnostic plan, reviewing your service information. More often than not, if you have a problem in calibration, it's a step in the sequence that you missed along the way. But I will say, for example, we did a Kia recently where we had the Kia triangles. We measured the vehicle out completely. We calibrated the vehicle or had everything set. We could use the right to repair, the J2534 software that Kia had available to us, and we could talk to the module. We could look at the data parameters of the module. But then when we were in the process of doing the calibration, the tool would not let us go to the next step. It kept looping inside this tool itself. So we reached a point where we could not move forward. I mean, we were truly using the Kia factory software, but it wouldn't let us go any further. So then we worked with a local Kia dealership, and we used their factory scan tool together with them, and their factory scan tool worked perfectly, but the J2534 software was broken. So what did we do? We submitted a service information request through the system that we have, and let them know that there appears to be an issue with the J2534 software. And they responded back later, hey, thanks for letting us know, because there was an issue with that calibration step, and we're going to employ a fix for that. So again, these are things that we find along the way, but having that information helps you go down the process, and then obviously document your legal implications. All right, so threw a lot at you in an hour, but hopefully now you've got a game plan. If you're not already calibrating vehicles, what are the steps you're going to take? Look at your facility. I think there's some great business opportunities for individuals in the future, that if you don't have the space, maybe there's an empty retail building down the street that the rent on it is super cheap, and it has a flat floor, no objects in the building, but it has a garage door where you can drive something through. You don't need a lift with this. You don't need any, special equipment. If you have an alignment machine and you perform the alignment on the vehicle and thrust angle and everything's good, you can move it to a flat base surface. That's what a lot of places we go to. An alignment is recommended, and as long as you have your alignment machine, you're good. But a lot of times they'll take the vehicle off the alignment machine and move it to a flat space, because the alignment machine is needed to align cars. The calibration area is a dedicated calibration area. So things to think about there. All right, Jason, I will open it up for questions.
All right, so if anybody's got any questions, you can go ahead and then start typing those now, or take yourself off mute here momentarily and ask them. But a couple things that I wanted to mention as Bob was going through that kind of struck me, that I wanted to just kind of bring up. Bob mentioned research. When you're working on a vehicle, even if you're not dealing with the removal and installation of a particular sensor or a camera, a lot of the times these systems are still going to require some type of calibration. So as you're building a repair plan, make sure you're taking that into consideration. If I'm just taking the glass out, I may still have to do a dynamic or static calibration. That the dynamic calibration may require certain parameters for distance or time or road conditions. So again, all those things you want to take into consideration. Make sure that you're building your repair plan effectively on that. The other thing is, you saw that one procedure that Bob went through here is pretty complex. So quite a bit of time to do some of that, and those times aren't going to be included in the replacement of that sensor or that camera. So you need to, again, do that research to understand exactly how long is this going to take, so I can make sure that you're accounting that for that as part of it. It's not part of that pre-repair scan, post-repair scan. This is a completely different operation. So that pre-repair scan, post-repair scan is more, identifying what diagnostic trouble codes might be out there, clearing codes, etc. But this can be a time-consuming process, as Bob mentioned. Maybe have two people in some of these cases as well, and certainly when doing a dynamic calibration where one of the technicians is driving the vehicle, having a secondary technician there to work the scan tool, so that we're not trying to monitor the road conditions as well as the scan tool is certainly something that is going to be important as well. And then post-repair test drives. So once I've done my calibration, once I've done everything on the vehicle, I want to make sure that I take into consideration, build my repair plan, that post-repair test drive, to make sure that that system works as designed. So I understand how the system's supposed to operate, how to engage and disengage that system. And again, you may need to have two vehicles in that, so that as they're driving down the road, adjusting adaptive cruise control or blind spot, that it's not you and an unassuming, another person on the road that's driving with you. It may behoove you to have, multiple people, multiple vehicles when doing that. And then one thing that I kind of thought about as we're going through here, because it can be complex, and math isn't always some of our strongest suits for a lot of us. During this kind of downtime, if you've got some downtime, maybe look up a couple of procedures on vehicles that you work on frequently. I think about, like, being here in the Midwest, a lot of pickup trucks and things of that nature. So maybe if I work on a lot of F-150s, maybe that I'm starting to see some vehicles that are equipped with advanced driver assistance systems, maybe log into Ford one day and just print out a procedure and use a vehicle, even if it's not a vehicle that's been repaired, but just kind of set it up as I would. Find the center line of the vehicles, make the measurements, try to get my line straight, and they're just kind of mark on the floor, just kind of a practice session without an actual customer vehicle, just to get us familiar with some of these procedures. I think in the beginning it can be pretty overwhelming, a lot of these calibration procedures, and trying to figure out where these targets are supposed to go. But once we get into it, it seems to be a little bit less complex. So I think, again, it's very intimidating at first, but if we do some practice runs in this downtime, there may be an opportunity for us to get more familiar with it. Maybe say, you know what, I'm about ready to kind of dive into this a little bit more. So right now is a great time for research if you do have some downtime. So we do have a couple of questions coming in here. Let's see here. What are your recommendations for screening / questions of a sublet if you're not going to be doing it in-house? So if I've got a sublet procedure, Bob, do you have any recommendations for what would I ask a vendor about to give me a confidence level that they know what they're doing when it comes to calibrations?
Yeah, that's always going to be a good question there, but I would ask for a check sheet, before you send a calibration over there. What are the processes that they use? If they can't provide you with a checkoff sheet, where they've checked the tire pressures and they wrote down how many pounds of weights that they put in the pack. If they don't have a check chart of some type that they can give you in the end when the calibration's done, then that's a pretty good indication that they're not documenting their process as well. Can they provide you with the screen capture of the scan tool at the very end that shows you that there is the successful calibration screen that said that the scan tool said that it's done? The other thing would be also the check sheet for road test. You brought up road test, and I didn't cover it as much here as I have done in longer sessions, but did they drive the vehicle with all the operational technology turned on? So did they use lane keep assist and lane warning? Did they sign off on that? If you look at a vehicle that's been delivered to a shop and let's say it had 10,100 miles on it, if the vehicle comes back to you with 10,103 miles on it, there's no way that they could have properly road tested the vehicle. So what's the mileage that they have applicable for there? Taking pictures. These are all things that I'm throwing out to you. These are all items that will be as part of our Opus IVS strategy when we're assisting remote shops, that they'll have to document all those steps, including taking pictures of, where was the target positioned, right? So not every step of the way, but we want to know the distance that the target was positioned, the scan tool capture messages, and then working off the information there. So those would be the recommendations. Now, certainly people can debate factory scan tool versus aftermarket, and I'm not trying to say, one way or the other in that regard. Our strategy will be to use the factory scan tool because we believe that in the end, if there are any legal implications whatsoever, that we've done everything in our power to do it exactly the way the OE recommended, with the service information, with the OE target, and with the factory scan tool. So that's our particular position. Even though that we're involved in aftermarket scanning, we believe that this particular aspect of the business would require usage of a factory scan tool.
And another question here on a vehicle when we've got depth R and I, both blind spot sensors or rear body panel replacement. Honda has some measurements for the body, the blind spot module. Can we use a car liner system to measure those, or will it need to be static calibrated before bumpers put back on? I think the answer to that would be both. We want to make sure that those mounting locations are proper location, but we may have to put, again, kind of like Bob covered here, when it comes to a lot of the Honda vehicles, if that module is behind the bumper cover, we're going to need to make sure that those are calibrated in the right proper locations before we put that bumper cover on, or we're going to have to go back and do that. And there are some of the vehicle makers out there will have a little bit of adjustment in those blind spot modules. Some other ones will not. So again, it's going to vary on the make, model, year of the vehicle as well. But again, that's where I think that research really comes in handy, making sure that you're following the OEM procedures on there, understanding exactly what is required for each individual vehicle.
Yeah, that's 100% on that. And it's interesting that some manufacturers, it's easy to find that collision, measurement information for the components, and others you don't find it at all. So that's one of the things that we need to keep pushing as an industry, is that the car manufacturers take it as seriously as we do, and maybe the measuring companies will become more in tune with that as well, to make sure that as they're measuring out the vehicles, that those particular points are documented maybe at a higher level. But it's interesting. We worked on a Kia not that long ago, and we were looking at the corner of the vehicles and the corner that had been repaired. But what was interesting is typically the blind spot sensors are positioned about the same distance at the back of the vehicle. This particular vehicle, the vehicle is shorter on one side or the other. I can't remember if it's the driver's side is just a little bit shorter in the corner than the passenger side. And the way we figured it out, we had found the measurement documents in the Kia factory website, started looking at the dimensions and said, wait a minute, this is truly shorter in the corner. So the bracket became very important to make sure it had the correct OE bracket. And then it had measurement strategies on the static part of it. And then in the end with that one, it had to have the panel moved around a little bit with the slide hammer in order to get it pointed the proper direction. But we've seen all kinds of stuff, I'm sure you guys have seen as well, with washers and nuts and all kinds of stuff shimming things out. You know, it's kind of interesting, some of the things you see when you get out in the field. But that's a good question.
Yeah. Dean's got a great comment here that I failed to mention as well. So I mentioned kind of practicing earlier. Another kind of idea would be to go over the dealership that you are working with, if you do work with a local dealership, and have a conversation with them, go through the procedures. Also, kind of relates to the sublet question earlier, but again, they've got some downtime as well, and a lot of their service departments right now might be a great time to get over there and work with them, and again, pull those procedures together, pull up some targets together, and do some of this work together. So kind of educating them as well as yourselves. And I think, again, another way to also kind of account for the time it's going to take if I do have to do some of these procedures to make sure that I do that. Bob, I got one question for you that just kind of your own opinion, I guess, if nothing else. But you mentioned the Honda and Acura challenge, where you just use the same measurements on the Honda vehicle as the Acura vehicle, found out that it wasn't correct. Do you think, number one, that with any particular vehicle, maker lineup, kind of Honda, Acura as an example, we're going to see, or at some point, start to see some more standardization of these calibrations? And number two, do you think we'll start to see some more standardization between vehicle makers? And a lot of these cameras and sensors might be made by the same, tier one supplier. Do you think we're going to see some more standardization of aiming and calibration procedures in the future?
That's it's an interesting topic, and we've talked about it at the SEMA meetings that I've attended. We've seen it at a few of the other expos where there were conversations. The OEs are kind of in a different world, right? They're trying to manufacture a car and get it out on the street. They buy the components from, I worked for Bosch for many years, and that's a question that I ask regularly to our radar and camera technology individuals was, okay, what kind of recommendations did you give the OE when you handed them that part? And there's, in the Bosch world, it's called a technical document, TKU, and it has all the documents in there, all the steps of recommendations. And this is where I looked at several OEs that had the same exact Bosch radar, right? Different part number. Honda had this part number, or Nissan had this part number. It's basically the same exact revision of radar. Some manufacturers used a triangle. Some manufacturers used a flat board. Some manufacturers wanted the flat board to be tilted. Some manufacturers decided that just as long as the board is flat and level in front of it, that it's good. And the response I get from many of them, it really depends upon the sophistication of the technology on the vehicle, right? If all you have is forward collision warning or lane keep warning or blind spot, the rules of engagement are less stringent, right? It's technology that's there, but the technology that they've added to the car still relies upon you being in charge of stopping your car. As you move into the more sophisticated technology with cruise control to zero, that's the one that I always feel the most nervous about driving, right? I just calibrated this car, a customer's car, and I took it out onto the street, and I now have to set the adaptive cruise control, and I've got to take it all the way to zero. I would not let a car out of my possession if I had to calibrate it and had, adaptive cruise control. I drive it exactly the way a car, but you got to put your foot over the top of the brake, right? So standardization needs to be there. Can we get there? I don't know. I mean, this has always been our biggest struggle in the industry, is the technology gets added so fast to cars that there's really not a catch-up point. And I think the issue that we have in many cases, working with OEs for years as well, is whatever they're working on now that's going to be delivered in the future, the engineers that worked on the car, the 2019 model car is already working on a 2022 or 23. So are they interested in going back and consolidating these concepts? That's the question that we're hoping to get more clarification on. I'm hoping that John at SEMA and some other organizations, you know, CIC and others that are working on it, to say, can we get some OEs together to start talking about standardization? Certainly SAE's out there, but I don't see anything at the moment moving us towards that direction. But maybe we as an organization, we keep pushing for that. But in the end, proper training solves lots of issues. So if you go to a training class, and we're developing one now, that would be a 2 to 3 day hands-on course that you would physically have to fly to a location to go to. We'd have all the cars, we'd have all the things that they would need. That's the piece that makes all the differences, is truly going through, just like you said, practice, practice, practice. If you do it, you begin to understand it. Then you can start to look at the instructions and understand, okay, what were they thinking? What were they doing? Do I need to do it this way every time, or is there a streamlined process? Rather than using a string, can I shoot a laser across those two marks to make my mark up front? We don't use strings anymore because we know we're more accurate with a laser, right? So once you start doing it, you become really good at it, and you become pretty efficient at it. But if you do it the first time, you know, the first time through is painful. It is just not fun and easy. But I think, you know, your question is properly suited. I mean, why do we have English dimensions and metric dimensions? Why some documents only have metric? That's been our challenge. We took some students, young students in high school, and started experimenting with, okay, come on, you know, we'll show you how to do this. A lot of them had no idea how to use a metric portion of the tape measure. Never used it. It's not taught in school. So interesting things.
Yeah, no doubt. One more question here. It's my understanding that the scan tool does not perform the calibration. The scan tool initiates the ECU to perform the calibration. Is that correct?
Yes, that is correct. In many cases, it is pushing a button on the scan tool that will put it in a dynamic calibration. Now, in those cases, those are typically cars that they're going to have criteria built in with that dynamic test, which meant that you're going to put it in a dynamic calibration. You're going to watch some LED lights on the dash, or it's going to count objects for a period of time until it gets the calibration point. Now, in the case of Nissan blind spot, for example, no calibration whatsoever, put it in its positions, make sure that it was properly positioned, that dimensionally was in the right spot, that's it. Clear the codes if there are any, drive the vehicle. There is no other procedure required for that. So typically, if it's scan tools involved, it's a initialize the dynamic, drive it according to the road test recommendations. Once the road test recommendations are complete, it's collected all the data at once, you'll have a successful message and you're off and running. It depends upon the car, right? That goes back to what's the year, what's the make, what's the model, right? What's the trim level of that model, right? You know, and how is it configured? So it can change, you know, the Honda Accord, 2-door or 4-door. Is it a coupe or not a coupe? It changes just within that environment.
All right, awesome. Well, with that, we're about out of time here. Bob, we really appreciate your time and your expertise and insight on this fantastic information. And we look forward to doing a lot more things with you in the future on this. So with that, I'm going to get it wrapped up here. Kristen, can you real quickly go over what we've got for tomorrow's lineup?
Yeah, I mean tomorrow, and I'm going to review because I forgot something earlier this morning, and I was like, oh, where are we at? So tomorrow is jam packed. We had a late addition to the schedule, 10 a.m. Central Time tomorrow. I'm also going to try to push that if the internet cooperates with me. Live stream to Facebook. We're going to be talking about Garage Keepers Insurance with reliable risk management. So he's got a presentation, and then it's your chance as an owner. If you have any questions about Garage Keepers, specifically coverages and how COVID-19 and some of that affects, that's going to be a great presentation. Noon Central Time tomorrow, Larry Montanez will be here talking about, it's an estimating presentation on how to estimate access and research to OEM procedures. So just what we were talking about here, looking at those TSBs, looking at the repair procedures and how much time it takes to actually accurately not only just repair, but estimate a car. And then how do you charge for that? Because that is compensatable time that needs to be covered. And then at 2 o'clock, Matrix Wand will be here to talk about more about ADAS, about using and measuring and ensuring that those brackets and those sensors are physically in the correct position before you begin that calibration, static or dynamic or whatever you do. We just got to make sure that's there. And I really want to make sure that's right before it heads to paint. So there's a couple different times we're going to check sensor positioning in that. So that's going to be jam-packed day tomorrow. If you've missed any of the webinars this week, they are all right now. Even Mike Anderson's this morning is now available for replay on YouTube. This one will be available for replay roughly in about an hour. So it'll be up there as well. And then this weekend, we will send you out, if you are registered, we will send you out the new lineup for next week with all of the access codes. We are realizing we're falling into some people's spam folders, and I've got about 700 emails, and I'm using the BCC feature so we don't all get each other's email. That would be drastic if some salesman got a hold of it and started sending you guys emails. So I think by putting it in BCCs, it's kicking it into your spam folder. So if you haven't got an email and you've been kind of going seminar by seminar, check your spam. And I will be exploring like SendGrid or something different for next week to see if I can not get caught in everybody's spam folder. So be patient with us. We're usually not sending out mass emails. That's not Collision Hub style. We don't do the whole get an email list and mark it to it. So we're learning. We'll get there. Jason's probably smarter than me. I should let him do it anyway. So but that's it.
Cool. And then one last thing. We haven't nailed down a date or time yet, but Bob, we're also going to try to do this presentation in Spanish. Is that correct?
Correct.
Awesome.
Yes.
Stay
So
tuned
I'll
for that.
work with Sergio, and we'll get that put together. Hopefully, maybe next week we can get that pulled off.
Cool.
That's
Kristen, for tomorrow morning for the risk management group, is that Facebook Live only or the link and
Both.
Facebook Live?
Both. So I publicly posted the link on LinkedIn, Facebook, everywhere. You can join us live tomorrow at 10 a.m. and participate and ask questions. And then I'm gonna co-stream it to Facebook. I just think this is such an important topic. I don't want anybody to miss it because they didn't register or something.
Yep. Cool. There you go, Dean. All right. Well, everybody, thank you. Have a great rest of your day. And we're looking forward to seeing you again tomorrow.